And as we all know, you can't judge a book by its cover. So if you just see what lies on the skin of the object, it doesn't tell you that it's necessarily natural.
Tonight, the scientific world faces a question it was never prepared to ask. For centuries, every strange rock that drifted through the solar system fit neatly into one of two boxes: asteroid or comet. It was simple, predictable, safe. But then came 3I Atlas, an interstellar object unlike any we've ever seen. Its glowing coma, its unexpected gases, its strange light signature, everything about it defies what we thought we knew. To most astronomers, the answer was obvious. It's a comet, they said. But Avi Loeb, Harvard astrophysicist, and perhaps the most controversial voice in modern science, isn't so sure. He argues that this time, the experts might be seeing only the surface and missing what lies beneath. Because in his words, you can't judge a book by its cover, and you can't judge an interstellar visitor by the ice on its skin. So, what if the biggest mistake in modern astronomy isn't about data, but about pride, certainty, and the fear of being wrong? What if, just like the Vatican in Galileo's day, science itself is refusing to look through the telescope? To understand why Avi Loeb's question matters, we first need to understand how scientists classify the unknown. When a new object is spotted in the sky, astronomers follow a simple rule. If it shines but stays silent, it's an asteroid. If it develops a tail, it's a comet. That's the taxonomy of our solar system, a naming system that worked for centuries. But like any map drawn too early, it only describes the territory we've seen, not the worlds we haven't. When an object travels through interstellar space for millions of years, it's constantly exposed to extreme cold, absolute zero temperatures where even metal would freeze. Loeb reminds us that anything moving through that cosmic night would naturally accumulate ice. So, when it finally comes close to the sun, those frozen layers boil away. To the naked eye, it glows, it hisses, it releases gas. In other words, it looks like a comet, but that's the illusion. Because, as Loeb points out, that shimmering halo of gas only tells us what's on the surface, not what's inside. Just as frost can hide metal beneath, or paint can disguise rust, the ice that evaporates from 3I Atlas reveals nothing about its true nature. And yet, within hours of the first observation, the verdict was declared. A comet, the headlines read. No debate, no hesitation. Because to most of the scientific community, it had to fit into one of the two familiar boxes. That's the comfort zone of human knowledge, labeling before understanding. But what if that habit, that urge to name, is blinding us? What if 3I Atlas doesn't belong in either box at all? Avi Loeb warns that when scientists cling to certainty, they risk repeating history, mistaking familiarity for truth, and convention for understanding, because every great discovery begins the same way, with something that doesn't fit. When data from 3I Atlas began streaming in, astronomers expected to see the usual fingerprint of a comet, traces of water vapor, simple organic molecules, and dust patterns that matched everything we've cataloged before. But this time, the fingerprint didn't match. Instead, the instruments detected carbon dioxide, cyanide, and, most puzzling of all, nickel without iron. That last detail stunned the experts. In natural comets and asteroids, nickel and iron almost always appear together, locked in metallic grains forged by stars. To see one without the other breaks the chemistry of what we understand about natural formation. Even stranger was the way 3I Atlas reflected sunlight. The object showed what scientists call negative polarization, a property rarely observed and almost never this strong. In simple terms, the light coming off the object was twisting in an unexpected way, as if the surface was made of something smooth, uniform, maybe even engineered. To many, these oddities could be dismissed. Nature, after all, is full of surprises. But to Avi Loeb, they formed a pattern, a quiet whisper that maybe, just maybe, this was something more. He's not saying it is artificial. He's saying it doesn't behave like what we know. And that difference, that tiny sliver of uncertainty, is where discovery begins. Think about it. Every known comet follows a predictable playbook. It enters the solar system on a graceful curve, heats up, releases water and dust, and fades as it drifts back into darkness. But 3i Atlas didn't follow the script. Its chemistry, its tail, even its brightness curve refused to behave. And its path through the solar system, aligned almost perfectly with the orbital plane of the planets, added another layer of mystery. Statistically, that alignment should be incredibly rare. To Loeb, it was as if 3i Atlas chose its route, slicing through the plane where all our instruments would be watching. For him, that's not proof of design. It's an invitation to pay attention, because, as he puts it, when every individual clue seems ordinary, but together they make no sense, you might not be looking at nature, you might be looking at something new. But in science, new can be a dangerous word. New means untested. New means controversial. And sometimes, new means unwelcome. So instead of asking why 3i Atlas looked different, many simply explained the data away, calling the nickel anomaly a coincidence, the polarization a quirk of angle, the path a lucky alignment. But what if all those coincidences are exactly what we should be investigating? What if the truth about 3i Atlas lies not in what we expect, but in what we're refusing to see? Avi Loeb often compares the story of 3i Atlas to another chapter of history, one written 4 centuries ago. When Galileo Galilei first aimed his telescope at Jupiter, he saw something no one expected: tiny moons orbiting a distant world. It was proof that not everything revolved around Earth, and that single observation shattered the universe as people knew it. But instead of sparking curiosity, it provoked outrage. The Church, the authority of truth at the time, declared Galileo a heretic. They placed him under house arrest, silenced his work, and erased his findings from public record. It would take 350 years for the Vatican to finally admit he was right. 3.5 centuries to say, we were wrong. Loeb tells this story not to mock religion, but to remind us that the impulse to suppress uncomfortable ideas didn't vanish with the Renaissance. It just changed shape. Today, the Church is not an institution of faith, but of consensus. The high priests are peer reviewers, the dogma is the standard model, and the heresy is simply asking the wrong question. When Loeb published his papers on 3i Atlas and its strange anomalies, the reaction was swift. Critics dismissed it as speculation. Bloggers called it sensationalism. Colleagues warned him that his reputation was at risk. But the pattern was familiar. History, it seems, never truly repeats. It only rhymes. In Galileo's time, the fear was theological, that humanity would lose its divine place in creation. Today, the fear is intellectual, that we might not be the smartest beings in the galaxy. Both fears come from the same root, the need to be central, to be right, to be the final authority. Loeb often jokes that he feels lucky compared to Galileo. He's not under arrest, just canceled on social media. But behind the humor lies a serious truth. Science, for all its progress, is still human. It's still ruled by pride, politics, and the quiet fear of being made irrelevant. And that's what makes 3i Atlas such a dangerous object. Because if it turns out to be something truly new, something that doesn't fit the textbook, then it won't just rewrite astronomy, it will force us to rewrite the story of ourselves. Perhaps that's why Loeb keeps repeating the same warning. Keep your mind open, otherwise you'll miss the universe when it knocks. Behind every scientific argument lies something far older, a quiet human fear, the fear of not being special, of realizing that we might not be the center of anything at all. Avi Loeb sees this fear as the true reason why many scientists reject the idea that 3i Atlas could be something artificial. Because if it is, even remotely, then we are no longer the smartest observers in the room. We become the ones being observed. To explain this, Loeb often turns to something close to home, his own daughters. When they were very young, he says, they believed they were the center of the universe. Everything around them, the attention, the voices, the light, seemed to confirm that. Until their first day of kindergarten. That's when they saw other children, other minds, other centers of attention. And in that instant, they matured. They realized the world was bigger than themselves. Humanity, he argues, is still before kindergarten. We look out into the night sky and see countless suns, countless worlds, and still insist we're the only ones here. We tell ourselves that we are exceptional, chosen, unique, because it's comforting. But what if comfort is the real illusion? Loeb believes Three-Eye Atlas might be humanity's first day of kindergarten. The moment we see another presence, maybe not directly, maybe just a clue, a trace, a glimmer, and realize that we are not alone on this cosmic street. It doesn't even need to be an alien probe, he says. It could simply be a tennis ball left behind in our cosmic backyard, something discarded or forgotten by another civilization long ago. The point isn't that it must be artificial. The point is that we should dare to ask. Because refusing to ask out of fear is not science, it's superstition wearing a lab coat. And if we let that fear guide us, we'll keep mistaking humility for weakness. We'll keep telling ourselves that our place in the universe is fixed, that there are no smarter children beyond our window, that we are still the only ones on the street. But Loeb suggests something else, something humbler and far more powerful. That maturity begins when we stop insisting we're at the center and start listening for footsteps beyond the walls of our world. In modern science, discovery isn't limited by imagination. It's limited by budgets. Avi Loeb likes to say, extraordinary evidence requires extraordinary funding. And right now, humanity is spending its money in all the wrong places. Across space agencies and university labs, billions of dollars are poured into the search for microbes, the faint chemical traces of simple life. Meanwhile, the search for intelligent civilizations receives barely a fraction of that. To Loeb, that's not a strategy, it's a blind spot. Because if intelligence exists out there, its signals might already be around us, waiting to be noticed. But you can't find what you refuse to look for. He calls it the funding paradox, the loop that traps science in its own logic. We don't search for extraterrestrial technology because there's no evidence it exists. And we have no evidence because we don't search. Round and round, the reasoning protects itself, and discovery never begins. Loeb argues that the universe doesn't reward closed systems. Progress comes only from risk, from testing ideas that might fail. But that kind of courage doesn't fit neatly into grant proposals. So instead of exploring the extraordinary, we stay safely ordinary. He points out that the entire field of SETI, the search for extraterrestrial intelligence, receives less annual funding than a single Mars rover mission. That's billions of dollars spent digging for microbes that might not survive sunlight, and almost nothing to investigate signals, probes, or technologies that could rewrite physics itself. It's not that the search for microbes is wrong, it's that it's incomplete. If our cosmic neighborhood contains both bacteria and builders, why are we obsessed only with the bacteria? Loeb uses a simple metaphor. Imagine you're walking down a street at night, looking for a friend who might be outside. You hold a flashlight, but instead of scanning the street, you point it at the ground, right in front of your feet. Hours pass, you find nothing. Then you conclude your friend isn't there. But the truth is, you never looked beyond the circle of light. That's where we are now, trapped inside our own beam of certainty. We're searching for faint chemical traces while ignoring the possibility of something louder, brighter, and infinitely more advanced. And Three-Eye Atlas might be that faint glimmer outside the beam, something drifting across the edge of our perception, challenging us to widen the circle. Because the real risk isn't in asking the wrong question, it's in never asking at all. Avi Loeb reminds us that humanity has a long history of not seeing what has always been there. Ultraviolet light existed long before we discovered it. Infrared radiation warmed our world before we had the tools to detect it. Reality doesn't change when we notice it. Only our awareness does. Loeb loves the story of William Herschel, the astronomer who accidentally discovered infrared light in the 18th century. He wasn't looking for invisible wavelengths. He was just curious about the colors of sunlight. But when he placed a thermometer beyond the red part of the spectrum, the temperature rose. Something invisible was carrying heat. Something our eyes were blind to, but nature wasn't hiding. It's a perfect metaphor for Three-Eye Atlas. Maybe it's not that the object is strange. Maybe we are still blind. Our instruments, our models, even our language are all built around the limits of our senses. We only detect what our technology allows us to imagine. Loeb explains that evolution shaped our eyes to see sunlight reflected from predators and food. That's why we see the visible spectrum, because it kept us alive. But in another world, orbiting another star, intelligent creatures might have evolved to see infrared, or radio, or X-rays. their eyes would reveal a completely different universe, one that exists right alongside ours, but remains invisible to us. If life adapts to its light, then maybe intelligence adapts to its physics. And if that's true, advanced civilizations might use forms of energy we can't even sense. Dark matter, quantum fields, or something we haven't named yet. To them, our telescopes would look like toys. Loeb imagines what that would mean. A civilization using dark matter as fuel, an engine with no visible exhaust, a perfect stealth drive, a propulsion system based on quantum gravity, moving faster than we can track, leaving no signal in our instruments. We wouldn't even know they were passing by. So, perhaps the question isn't whether they're here, but whether we've ever learned how to look. And maybe, just like Herschel's thermometer, 3i Atlas is quietly raising the temperature, a sign that something invisible is brushing against our reality, waiting for us to notice. Avi Loeb's optimism about discovery always carries a shadow, because in the vast, silent universe, silence itself might be a warning. He often refers to what science fiction calls the dark forest hypothesis, the idea that the cosmos could be full of life, but most of it stays hidden. Every civilization, knowing that predators might be listening, keeps its lights off. Every forest, no matter how vast, is quiet before the hunt. If that's true, then the civilizations that make themselves visible, the ones who shout into the dark, may not survive long enough to keep shouting, and that, Loeb says, should make us think carefully about our own behavior. For a century, humanity has been broadcasting radio waves into space, signals strong enough to travel across light years. Television, radar, the chatter of our technology, all of it leaking into the void, announcing our presence to anyone who might be listening. Maybe, he suggests, that was a mistake. Loeb's worry isn't superstition, it's logic. If 3i Atlas is artificial, it might not be a friendly visitor. It could be an observer, a silent scout, drifting through the solar system to map what kind of creatures live here. Or maybe it's simply a remnant of someone else's caution, a fragment from a civilization that learned to hide long ago. He doesn't say this to frighten people, but to remind us that maturity also means prudence. When you walk through a dark forest, you don't shout. You listen. And maybe that's what we should be doing now. Listening instead of declaring. Observing instead of assuming. Because if the universe really is a dark forest, then every flicker of light, every signal, every comet, every mysterious visitor might be both an invitation and a warning. In the end, 3i Atlas may turn out to be nothing more than a strange comet, a shard of ancient ice wandering through the dark. But that's not the point. The real question is what this moment says about us, about how we react when the universe hands us a mystery that doesn't fit our rules. Avi Loeb often says that being wrong is not a failure, it's an opportunity. Galileo was wrong about some things too, but what mattered was that he looked even when others refused to. He asked questions that felt dangerous because they challenged certainty. And that's what science is supposed to do. Maybe the greatest danger today isn't that 3i Atlas is artificial. Maybe the danger is that it could have been, and we chose not to find out. Because the cosmos doesn't reward arrogance. It rewards curiosity. And if there's one lesson the universe keeps teaching us, it's that humility is the first step toward discovery. So, perhaps centuries from now, another generation will look back at this age, at the telescopes, the debates, the resistance, and ask the same question we now ask of the church in Galileo's time. How could they have missed what was right in front of them? 3i Atlas may not be the proof of alien life, but it could be something even more important, a mirror showing us the limits of our imagination. And if that's true, then maybe the ones who are wrong are not the dreamers, but the ones who stopped dreaming. If you've made it this far, you've just traveled through 20 minutes of mystery, science, and imagination, all orbiting around one question. What if the experts are wrong about 3i Atlas? Maybe it's natural. Maybe it's not. But either way, it reminds us of something bigger, that curiosity is fragile, and truth rarely lives inside our comfort zones. Avi Loeb's message isn't rebellion, it's humility. He's not asking us to believe in aliens. He's asking us to believe in the unknown, to admit that our map of the cosmos is still incomplete and that wonder is not a weakness, because every great discovery begins with doubt, and every generation faces a choice. to defend what we think we know, or to look again and see what we've been missing. So, as 3i Atlas continues its silent journey beyond Mars, past the warmth of our sun, and back into the deep interstellar dark, remember this: we are only at the beginning of our education in the universe. If the truth is out there, it won't come to those who wait, but to those who dare to look differently. This is the story of 3i Atlas, and perhaps the story of us. If you enjoyed this exploration, subscribe for more stories that challenge how we see the universe and ourselves.